Broadcasting from Boston, Massachusetts, the Smart Cities podcast is the only podcast dedicated to all things smart cities. The podcast is the creation of ARC Advisory Group's Smart City practice. ARC advises leading companies, municipalities, and governments on technology trends and market dynamics that affect their business and quality of life in their cities. To engage further, please like and share our podcast or reach out directly on Twitter at Smart City Viewpoints or on our website at www.arcweb.com/industries/smart-cities.
Welcome, everyone. This is Jim Frazer, welcoming you to another episode of the Smart City podcast by ARC Advisory Group. I'm the Vice President of Smart Cities and Intelligent Infrastructure here at ARC. And today we'll be interviewing a guest, Craig Waltzer of GovCom, on fever screening thermographic cameras, which is a very important topic in this coronavirus impacted world of ours. So Craig, welcome and thanks for joining us today. How are you?
Good, Jim. Nice to be here.
Hey, great. Well, before we get into all the technical details, can you tell us a little bit about yourself and your company?
Sure. Again, my name is Craig Waltzer. I'm the president and CEO of GovCom. GovCom has been in the intelligent transportation system business since 2012, and we've recently transformed into the smart city world, where we've launched our own platform and bringing on different applications, and the fever screening cameras are our latest innovation.
Well, that's great. So for those of us who might not be very conversant in the domain, we know there's cameras out there. There's thermal imaging cameras. There's high definition cameras. What's the difference between all of those, including the definition of what's a medical device camera versus perhaps a regular thermal camera? Can you touch on all of that?
Sure. Well, our cameras that we use for fever screening is deemed to be a medical device because of its accuracy. Its accuracy is plus or minus a half a degree. Now, the reason that there's a differentiation between the different thermal cameras are that the standard thermal cameras that I'll sell for an ITS, Intelligent Transportation System application, will be plus or minus 8 degrees. So there's a big difference in the sensor that goes in that camera. Another difference is that these cameras both have an optical and a thermal mode. So you can pull different streams off the camera. You can be pulling a high definition stream off the camera, but the thermal stream that you're pulling is more of a sensor. And what you're actually doing is that you're measuring a person's body temperature. Their forehead is, the camera does, something similar to a facial recognition where it'll recognize the person's face and then, go right to that forehead to take the temperature. So there is some uniqueness to this camera that are not in other thermal cameras, even though it is a dual purpose camera, both optical and thermal.
That's interesting. I know that, in preparing for our podcast today, I did a little bit of homework and, expanding on your intelligent transportation systems temperature range. I see that, ITS deployments have a plus or minus 8 degree C accuracy. Industrial thermographic cameras are plus or minus 4 degrees C. Fire detection is plus or minus 2, and medical is plus or minus half a degree. So I could see that they are more accurate and likely cost a little bit more.
Yeah, like with anything else, the higher the grade, the more expensive it's going to be. And this particular device, since it is deemed to be a medical device, is required to have Food and Drug Administrative certifications as well. So
Right.
that's something that sets it aside. It's another certification that's required, so that somebody trying to sell a device like that whoever's going to be buying it better make sure, especially if it's for use here in the United States, that it have, besides the UL and the FCC certification, it also have an FDA certification.
Interesting. I know this technology has been around for a long time, and one of the larger applications that we come across at ARC is actual thermal imaging cameras for substations and for the power industry, where if you can record the temperature of a component or of all the components in a substation, well, if you see something that's out of its temperature specification, something that an operational anomaly may happen because it's overheating. And essentially, it's the same theory here with humans. So, form factors. How large are these cameras? How can I mount them? Where can I use them? Can you talk about that a little bit?
Sure. Well, there's two form factors that we offer. There's a handheld form factor, and for instance, I was just down in the country of Panama, and I was down there right as this coronavirus epidemic first started. Before they let us off the plane, a person from their health department came on with a handheld device, and she took everybody's temperature. So this is something that it's portable. Our particular unit connects via Bluetooth or Wi-Fi to a tablet or a PC, and it's something that is certainly mobile. The other type of form factor would be what I call our bullet style or a fixed our fixed camera, and that's for use at further distances. The handheld, usually 3 to 6 feet. The bullet camera, the fixed camera, anywhere is from 8 to 30 feet. And the bullet camera is typically mounted on a wall, and it's best deployed in a controlled environment, where people are herded like cattle, such as like a building entrance or an airport, or a port disembarkation point.
Okay. But before we get into I've got a couple of questions about the software that manages, say, looking at multiple people at the same time. But let's first talk at some of the more foundational issues about perhaps operating environment. Are these cameras available for indoor and/or outdoor environments as well?
Yeah, the answer is yes, but they work best indoor, like in an air-conditioned environment with limited exposure to like background objects with that have temperatures higher than the human body. Operating these devices outdoors in uncontrolled environments, may cause accuracy fluctuations. Also
Right.
what we like to tell our customers is that it's always best if like if you're, let's say, in an airport, that you have it at a security checkpoint lines, not at the location where that person might be coming in from the outside. We're coming in from, let's say, a hot or a cold environment. You'd like for that person to be in a stable environment for a couple minutes before they before they're monitored in such a way. It's always best for accuracy purposes.
Sure, that makes absolute sense. So what actually happens when an image is recorded and a person's facial temperature or an area on their face exceeds a set value?
Well, what happens is that when using the handheld, what you're doing in advance, you're setting a maximum temperature value. So that turns red on the screen, on the on-screen display, and flashes red when a value exceeds the maximum temperature value. And the audio alarm will also sound. When using a bullet style or a fixed camera, the camera is connected to to software that we provide that'll alarm out, in a way similar to handheld. But the software, especially when you're connecting to a network, can alarm to like an SMS message, an email, or trigger a light, a siren, or whatever other type of auditable notification. Kind of like when you walk through a metal detector in an airport and then an alarm goes off. That's kind of what
Okay.
what you're hearing.
So what is there guidance from national or international bodies about what temperature you should set your set points at?
Well, we recommend setting it, let's say, a half a degree over the human body temperature. So that would be 37 degrees Celsius or
Okay.
98.6 Fahrenheit. This way, what we're doing is we're working within the the plus or minus you know acceptable error zone, so that you're gonna reduce false positives.
Okay, that makes sense. Um, Now, software. I could see it's a relatively straightforward process to be, on an aircraft with a handheld sensor and scan each passenger. But when people are coming out of, let's say, an arrivals gate at an airport, um, and you have a fixed thermographic sensor, what does the software do there? And if alarm's triggered, does it know what person is triggering the alarm? Can you explain that in a little more detail?
That's something that it's a little tricky. When I say it's a little tricky, I just had this conversation with a customer yesterday, because what you always want to do is you always want to, protect a person's personal information. Okay, so it gets into it gets into areas that there's a lot of legislation out right now. So what this one municipality didn't want to do, they didn't want to snap the picture, but we can snap a picture so that a person can be identified as in that SMS message to have a photo sent. So since it's an IP device, there's a lot of latitude as to what we're able to do and the notifications that we're able to send. But it's really going to be up to the municipality as to how they want to move forward with the with the notifications in order to protect privacy and also comply with with the certain rules and laws, such as if they do snap a picture, does that picture have to be maintained for a year or something to that effect?
Right.
So it kind of gets into that HIPAA area, where we have
Exactly.
medical information that you don't necessarily, the municipalities don't want to be able to specifically retain that information. So it's really up to the it's really up to the customer, the municipality or the state, the government official, as to what they want to do. But we're very flexible as far as the information that it can provide, because it is an IP device.
Oh, great, great. Well, Craig, I think you answered my next question. But if I have a networked fixed camera at an arrivals gate at an airport or at a cruise ship terminal, does it require a operator to look for people's faces, perhaps highlighted in red or highlighted somehow, and for that person to then go and pull them out of the line? Or um, how is that typically configured, that management process?
Again, this camera is configured similar to a facial recognition camera, where what's happening is that we can capture several individuals that are within the camera's view. We capture their face, and the camera makes a decision where that person's forehead is, and they direct the sensor to the person's forehead to capture the temperature. So what's actually happening is that it does not require human interaction, and the thermal sensor is just that. It's a sensor. So there was some question about privacy, like, is it an X-ray, like you're seeing through
Right.
people? You're certainly not seeing through their clothes or bones or anything to that effect. But those are all questions that I am asked, and that is something that we're very cognizant about. And again, we're capturing the person's face, determining where to capture the temperature, and then making a determination, and then sending that information. And it's generally text information although we can snap an image because it is a dual, there are two lenses. There is an optical and a thermal lens, but the thermal is just capturing heat. So,
So,
and that's how it's doing its sensing.
well, thank. That's interesting. So can you talk about how does the software then recognize if I have a sequence of people, 2, 3, 4, 5 people in a line or in a group? How does the software configure a message or an alarm to say person 3 out of 5, or the person in the upper left of the picture is the person that triggered the alarm?
It's similar to like a red light camera. Okay, when several cars are going through that intersection, and basically what's going to happen is that it's going to capture the person or persons that have the high fever, okay, through the sensor, okay, and it's going to identify, in the image, it's going to identify the the person of interest. And again, if there's not going to be an image because of HIPAA type concerns, then and if 3 people are in the same image, you might have to ask those 3 people to to go for for like a handheld camera check or something to that effect. But it's something that we like the idea of taking the image, but again, it's just about balancing what we can and can't do in complying with the law.
No, that's very insightful. That I would assume, and I'm not an attorney, that if you do collect forehead temperature from people and then take their image, that could very easily be classified as HIPAA regulated data and information that might not be allowed to be shared very far or at all. So, perhaps I think that's an interesting approach to surmount that obstacle by then simply requesting everyone in the picture to go through a secondary scan.
Well, what we've been able to do in the ITS world, because as most people know, and the cameras that are out on the road, they don't record. The reason that they don't record is, there are 2 reasons. Number one, the record keeping requirement as far as all the attorneys that would be looking for crash reports would be, too cumbersome. Number 2, the amount of storage that would be required, would be, kind of ridiculous, and it would cost a lot of money. So what we've done is we've put SD cards in these cameras. So, the images are allowed to be seen locally. Okay. But they don't travel over the network, and they never get to whether it's a Department of Transportation or to, other, a municipal government entity. So if the DOT or other government entity never has it, they don't have to maintain it. So there are some ways to, to have it so that, on an SD card locally, it can be assessed, and, that it's a way to be able to, put the camera to better use and be able to go back and review, something that happened recently by accessing the SD card on the camera. Okay.
So I'm guessing, given the coronavirus, situation in the U.S. and around the world, I think we all can guess about, application areas of airports and seaports and hospitals, government locations, any type of public facility. How about product availability? We see that, the lack of quantities of ventilators and even hospital masks is negatively impacting the response in a lot of areas of the world. Are these in stock, or what's the lead time on something like this?
I don't stock them because they are, somewhat costly, but the lead time is within 30 days. If somebody places an order, I could generally get my hands on it within 3 weeks, and within 30 days they'll have the cameras.
Okay. How narrow do you need special training to use a camera like this? Do you need to be a doctor or a nurse?
No, all the technology is in the camera. Again, we're capturing that face. We all know what the normal human body temperature is, 98.6 Fahrenheit, 37 Celsius. So if again, these cameras, they don't necessarily detect coronavirus. Coronavirus is a medical condition detected by specific medical tests. Our fever screening, cameras detect high fever, which is just a symptom of coronavirus, as well as other elements. So this product is used for preliminary screening of people with fever. So after an alarm is triggered, a specialized medical thermometer should be used to confirm if it's determined that person needs to go for further medical testing. This is just the front line on okay, somebody's just entered your airport, your seaport, your train station, whatever the case might be, and this person needs to be dealt with differently than the rest of the people.
So if I I could see with the software that supports the sensors themselves, you can consider this a fever monitoring platform of sorts. Is there a limit to the amount of cameras that the software and the management system can support? Or what's a typical? Go ahead.
Yeah, everything has limits, okay, but the limits are generally on the hardware side, not the software side. So, we've had deployments with not necessarily these cameras, but more than 1,500 cameras on the software that we provide. So there's not we're not going to get bogged down if there's a lot of cameras on the network. And the reason is because the computing is not being done on board the camera. So you're capturing the face on the camera, you're taking the temperature on the camera. The VMS, the video management software, is more of a management tool than anything else. So we're not, all the heavy lifting, I should say, is being done on the camera side.
Oh, that's fascinating and is really forward thinking. This really is a fever sensing edge device. And
yes.
As we as we know, with everyone from working at home, the internet has not been as reliable as it might have been even a few weeks ago. Calls are getting dropped and different applications aren't working the way we might expect them to work. So it's very important to conserve that bandwidth, and edge device processing, particularly sending only the critical data and not a huge picture file, is very important. In a way, this is analogous to me to license plate reading edge devices, where very often, well, Craig knows because we're both based here in South Florida, that there's license plate reader cameras that only send the actual alphanumeric characters from the license plate to our state motor vehicle office to check is it a valid a license plate? Is the car stolen? Is there insurance? All of those sort of things. Instead of sending the graphical picture, which is many orders of magnitude larger, on the internet up to Tallahassee and having the processing done there. So all of that image processing is done, in a small little box on a pole out there on the street side, and the same thing, happens here in this edge device as well. So that was just a superb design consideration.
Sure, and look, we're doing the same thing with our vehicle video detection. We're taking an NVIDIA, edge device, and like a Nano or TX2, and we're putting it out in the field. Everything we do is on the edge, and we're doing all of our computing on the edge. And instead of having to stream back to the traffic management centers, same thing like you were saying with the license plates, we're sending data, back to the traffic management centers, not video, which of course video is very fat.
Right. Exactly. Well, Craig, this has been a great overview of fever monitoring and fever detecting thermographic high definition cameras. Um, what is there anything else you'd like to add before we close our discussion today?
That what we're doing as a company, we're responding to this worldwide emergency, and it's something that just like 9/11 changed the way that the world operated. Coronavirus is doing the same thing. We're going to wake up when this is all over, and we're going to see people wearing masks, people wearing gloves, people acting differently than they ever have. So it's going to be a new fact of life, just like taking your shoes off at the airport when you're walking through the detectors. It's going to be a new fact of life that these fever screening devices are going to be in public places throughout the world.
There's no doubt about that. I know that after 9/11, on the ITS backbone, and Craig, you probably know this as well as I do, that there's mass spectrometers out there that are examining the air quality to see if there's anything, any compounds that might indicate a bad actor in the environment. They're all through New York City and around a lot of state and federal institutions. I can imagine the same thing happening here. To give,
look, this is what Smart City is all about, Jim.
Yep.
You and I both know because we've been involved with it. You have environmental sensors. You have the light controllers. Now these fever screening cameras, public Wi-Fi, parking. There's just so many applications that the smart city infrastructure is really taking off, and it's going to become the next. It is the new normal.
It really is. Well, Craig, thank you very much for joining us today, and thanks to everyone for listening. Again, this has been Craig Waltzer of GovCom talking about fever monitoring thermographic cameras, and I'm Jim Frazer from ARC, and we hope to see you again on our next Smart City podcast. Thank you very much.
Thank you, Jim.
Broadcasting from Boston, Massachusetts, the Smart Cities podcast is the only podcast dedicated to all things smart cities. The podcast is the creation of ARC Advisory Group's Smart City practice. ARC advises leading companies, municipalities, and governments on technology trends and market dynamics that affect their business and quality of life in their cities. To engage further, please like and share our podcast or reach out directly on Twitter at Smart City Viewpoints or on our website at www.arcweb.com/industries/smart-cities.